Okay, for question number 32, this is question number 32, part B, we have to find the product of the matrices, and hence means we have to use this to solve the following system of linear equations. So if we write these system of equations in the matrix form, it will be AX is equal to B, and A matrix is 1, 2, negative 3, and this is 2, 3, 2, 3, negative 3, and negative 4. This is the A matrix. And X matrix will be X, Y, and Z. And B will be the matrix of the constants, which are negative 4, 2, and 11. And if we look at this matrix, this is the A matrix. And this one, uh, let's say this is B matrix. So let's multiply them. So clearly the product, if we find the product of these two matrices, this one is the A matrix. Okay, so I'm going to find the product now. The first matrix is 1, 2, negative 3. This is 2, 3, 2. And the third row is 3, negative 3, negative 3, and negative 4. This is our A matrix. And we have to find its product with this is negative 6, 17, 13, and 14, 5, and negative 8, and then negative 15, 9, and negative 1. Okay, so let's find out the product, and we know how to find the product. So one, we have to add the product of the respective elements of the row and the column. So 1 into negative 6. So first row and first column, this is negative 6 plus 28 plus 45. This is the first element. Second one is the same row with the second column. So this is 17 plus 10 minus 27. And then 13, negative 16, and plus 3. Okay, now second row with all the columns. So 2, this is negative 12 plus this is 42 and negative 30. This is 17 to are is 34 plus 15 plus 18, 26 to negative 24, negative 2. Okay, this is negative 18, negative 42 plus 60. 17 into 3 is 51, negative 15, negative 36. This is 39 plus 24 plus 4. Okay, so now we have the product as, so minus 6 plus 28 plus 45 is 67. So 17 plus 10 minus 27 is negative 17, so this is 0. 13 minus 16 plus 3 is 0. Negative 12 plus 42 minus 30 is 0. 34 plus 15 plus 18 is 67. 26 minus 24 minus 2 is 0. 18 minus 42 plus 60 is 0. This is 51 minus 15 is 36 minus 33 is 0. And this is 67. Okay, so this is now I can take 67 common here. So this 67 is common. And now it's 1, 0, 0, 0, 1, 0, 0, 0, 1, which is an identity matrix. So we have got the product of this A. Let's say the other matrix was B. So this matrix was A and this matrix was B, and we have got this product as 67 into the identity matrix. So A into B is equal to 67 into identity matrix. And I can write it as A into, let's take shift 67 to this side. So this is 67, 1 by 67. So 1 by 67 into B is equal to identity matrix. Now we know that if AB is an identity matrix, then B is the inverse of A. Then A inverse is equal to B. So that means here the A inverse, A into 1 by 67 into B is identity matrix. So that means the inverse of A is 1 by 67 into B. So we have got our A inverse. So A inverse is equal to 1 by 67. Let's write down the matrix. The B matrix here was, let's write down the B matrix, and or let's leave it as it is. Or the B matrix, what is negative 6? This is negative 6, 17, 13, and 14, 5, and negative 8, negative 5, 9, and negative 1. Okay, this is our. Now we have to solve the following system of equations. So let's write them in the matrix form, and I have written them in the matrix form. So if we have to write them in the matrix form to solve the following system of equations, we can write them as Ax is equal to B. Okay, so we have got our A inverse. I will just keep that. Okay, now to solve this system of equations, we are going to write them in the matrix form, which is Ax is equal to B and x is equal to A inverse into B. So here x has the variables in the matrix form, and A inverse B is 1 by 67. So this is 1 by 67. Okay, and negative 6, 17, 13. This is inverse 45, negative 8, and then negative 5, 9, and negative 1. And we have to write the P matrix, which has all the constants, so negative 4, 2, and 11. So it's given in the question that you find the product of these matrices, and from there we have got the A inverse, and now we can use this to solve the following system of equations. So we have got A inverse from their product, and now we are using that to find the solve the system of equations. So let's multiply these two equations, which is equal to 1 by 67. So I'm going to multiply this. So negative 6 into 4 is 24, 17 into 2 is 34, plus 13 into 11. So 13 into 11 is 143. So this is 143. Now 14 into 4 is negative 56. And plus 5 to the is 10 and negative 88. Third is 60 plus 18 negative 11. Okay, so this is equal to 1 by 67, and 24 plus 34. This is 3 plus 4, 7. 7 plus 4 is 11. And then 4, 3, 7. 7 to 7 plus 2 is 9, and 1, 10. And then it's 1. So 24 plus 4 plus 3, 7 plus 4 is 11, and 4 plus 3, 7 plus 2 is 9, and 1, 10. So this is then 201. Okay. Now, this is negative 56, negative 56 and 88. Negative 88 gives me 14, and this is 44. So negative 144 means it's negative 134. This is 18 minus 11 is it's, so if we 18 minus 11 is 7, and plus 16 is 67. Okay, now let's divide these numbers with 67. So 60, 201 is 67. Let's divide 201 by 67, which gives me, you have to divide 201 by 67. So 67 into 3. So this becomes 3. This is 3. And next is 67 into 2. 67 into 2 is 134. So this is negative 2 and 1. So we have the values 3, 2, and 1. So that means our matrix X, Y, and Z is equal to, we have got the product, which is 3, negative 2, and 1. So this is 3, negative 2, and 1. So 3, negative 2, and 1. And hence we can write that X is equal to 3, Y is equal to negative 2, and Z is equal to 1.